There is a toy car. Toy car is composed of a rectangular block of mass m that is fixed on 4 wheels, each of mass small m, radius r, that can roll over it, and it is tied with a spring of force constant k. Coefficient of friction is mu. You have to find maximum amplitude. You have to find maximum amplitude. Maximum amplitude such that it starts to slip on this. That means frictional force start acting on this. First, since it is oscillating with small amplitude, so applying conservation of energy, that at any point of time total energy remains constant, that is half kx square plus half total energy, kinetic energy. Since these wheels are also rotating, so there must be rotational kinetic energy as well, half I omega square equal to constant. So solving this, what we can get? Half kx square plus half m plus 4m v square plus half momentum of inertia of these 4 wheel is 4 into half mr square, small mr square, is equal to constant. Solving this, what we are getting? Half kx square plus half m plus 6m v square equal to constant. This r into omega is v. So here this can be cancelled. By taking the derivative of these two, you get 2kx into derivative of x plus m plus 6m, 2v into derivative of v equal to 0. From here you can find out 2 can be cancelled. This x dot is velocity, this is velocity, this is acceleration. So acceleration is equal to minus k m plus 6m to x. This is acceleration. Now we have to find the maximum amplitude at which the frictional force start acting. First we find the frictional force. Maximum frictional force that can act here is mu into m plus 4m into g. And to find the restoring force, first we have to find restoring torque, because the wheels are rotating. Restoring torque is equal to, you can say that F into R is equal to I into alpha. That is F equal to I alpha upon R. I is equal to moment of inertia of these. Moment of inertia of these will be equal to 2mr square of 4 wheels. Alpha upon R is equal to A upon R square, that is 2m into acceleration. Acceleration is equal to k upon m plus 6m, and this is the maximum amplitude. So this will be equal to 2m k upon m plus 6m into maximum amplitude. So this F is equal to this. Therefore we get here 2 mKa upon m plus 6m is equal to mu into m plus 4m into g, or maximum amplitude is equal to mu into m plus 4m m plus 6m g upon 2mk. So this is the maximum amplitude. Next question is, there is this block tied between two springs, both having spring constant k. This is mass m. Now if it is compressed to one side, if it is moved to one side such that it compresses the spring by distance x, that means energy is stored in this spring as well as in this spring. That means total energy stored here is half kx square plus half kx square, and as it comes to it, that means it is taken here by distance x. When it comes at this position, that is the normal position, there is no extension or compression in the spring, that is, it will be converted to half mv square. So this becomes kx square is equal to mv square, that is 2. So v is equal to 2k upon m. This is the answer. Next question is, there is a block of mass m equal to 1 kg, and this is a surface. The surface is such that this mass is 1 kg. From here to here, there is no friction. Here friction is given as 0.2. The spring constant of this spring is 200 Newton per meter, and when it strikes with this, it gets compressed by 8 centimeter, that is 0.08 meter. So in first part you have to find the work done by spring force. What is the work done by spring force? When you are calculating work done by spring force, no other work is to be considered or no other energy loss is to be considered. Simply half kx square is the work done due to spring force, that is half into 200 into 0.08 square. You solve it, you will be getting here 0.64 joule. Second part is increase in block surface thermal energy. From here friction starts acting, that means from here to here there is no frictional force, no work is done. That means in this portion the work is done due to friction, and that is counted as thermal energy. That thermal energy is of the block as well as of the surface, and that is, you can calculate, you can say that increase in block surface thermal energy is equal to mu into mg into distance, that is mu is 0.2, this is 1 into 10 into distance is 0.08, you can say that is 0.16 joule. This block surface thermal energy is the sum of block thermal energy plus surface thermal energy, that is equal to 0.16 joule. In third part it is given as block thermal energy is 0.06 joule plus surface thermal energy, that is equal to 0.16 joule. Therefore surface thermal energy is equal to 0.1 joule. In last part it is to be find out that what will be the speed of the block when it reaches here. It will be decided by the total energy lost in the further process. total energy lost in the further process is half kx square plus total thermal energy. That was the kinetic energy. Let's consider this point A at A. So from here you can calculate half kx square, it was 0.64 joule, 16 joule, that is equal to half mv square, m is 1, that is v square. So from here you are getting v square is equal to 0.8 into 2, that is 1.6. So v is equal to, that is 1 point, approximately, not exact, approximately 1.26 meter per second. Both are equal masses. This is frictionless surface. There is no friction. There is a spot here at a distance of 24 centimeter, and this is also the unstressed or unextended position of, unextended length of spring, normal length of spring. We have to find its velocity. At which point? Here, when it just leaves the surface, because as it comes here, spring will be stressed, posed by distance x, restoring force will be kx, that means tension will be kx. So vertical component is kx, this is theta, kx cos theta. Here this is mg. That means when kx cos theta equal to mg, it will lift up. Kx cos theta equal to mg. What is cos theta here? If this is 24 and spring is extended by x, that means this length will become 24 plus x. If this angle is theta, this is theta. So cos theta is 24 upon 24 plus x equal to 2.4 into 10. This k is given to you as equal to 13 Newton per meter. So this is 13 24x upon 24 plus x equal to 24. That is simplifying these 13x equal to 24. X will be equal to 2 centimeter. That means this length becomes 26 centimeter. And this becomes 26 square minus 24 square under root. That is equal to 10 centimeter. That is 0.1 meter. So this is 0.1 meter. That means as 2.4 kilogram is displaced through this distance 0.1 meter here, this block also comes 0.1 meter downside. That means there is, we can say there is decrease in potential energy is equal to using work energy theorem. Decrease in potential energy, that is 2.4 into 10 into 0.1 is equal to increase in kinetic energy, that is half into 2.4 into v square. If this is having velocity v, this is also having velocity v. That means this plus this into 2 plus this has component kx sine theta in this direction. this is kx sine theta in this direction. That means plus kx sine theta into 0.1. So here this is 2.4 equal to 2.4 v square plus kx is, k is 200, x is 0.02, sin theta becomes 10 by 26 into 0.1. Simplifying this, you will be getting 2.4 is equal to 2.4 v square. This is 204, 4 by 26, approximately 0.15. So 2.4 v square is equal to 2.25. This implies v square equal to 2.25 divided by 2.4. So v is approximately 2.25, 2.4, approximately this will come 0.97 meter per second. So this is all about these questions. Hopefully you must be benefited from this. Thanks a lot.